Okay, so we're going to start off with the saponifiable lipids, and the first ones we're going to talk about are the triglycerides. And you've heard of triglycerides. They're the majority of fat in your body and in the food that you eat, triglycerides. So if you're having some butter or you're having a steak that has quite a bit of fat in it, or you're having what else has a lot of fat in it? Some cream cheese or just regular cheese. It's all a whole bunch of triglycerides, all right? And in your body, in the adipose tissue, in your fat cells, mainly stored as triglycerides. So what is a triglyceride? The prefix tri means three. So what it is, it's a glycerol molecule, and we'll draw the structure of glycerol attached to three fatty acids, okay? So what is a triglyceride? It's one glycerol molecule plus three fatty acids. So now we need to talk about, well, what is a fatty acid? There are a whole bunch of fatty acids that we're going to learn. And there are saturated fatty acids and unsaturated fatty acids. What does the term saturated mean? Again, this is why we did organic before biochemistry. Remember when we talked about the difference between alkanes and alkenes? Alkanes are saturated with hydrogens. They have no double bonds. And alkenes are unsaturated. They're missing some hydrogens and they have double bonds. So the saturated fatty acids have no double bonds. Okay? The fatty acids that we need to know, be able to recognize the name and the structure, are these. These are the ones that you need to know that are under the category of saturated fatty acids. So, lauric acid, what does this mean? It means that it has 12 carbons and no double bonds. Okay, this colon 0 means no double bonds. Myristic acid has 14 carbons and no double bonds. Palmitic acid, 16 carbons, no double bonds. Stearic acid, 18 carbons, no double bonds. Arachidic acid, 20 carbons, no double bonds. All right. So what is the structure? What does it actually look like? We get that there's, 12 carbons, 14 carbons. Well, do you remember the carboxylic acid functional group? That's where that term acid comes from. So you have a carboxylic acid group, and that would be carbon 1. And then after that, a bunch of carbons, CH2, CH2, CH2. So let me draw you an expanded structure and a line drawing for these fatty acids. So I'm going to erase this up here, and I'm going to show you what we're going to do. So let's say here's my carboxylic acid group. Okay, do you remember that? Carboxylic acid, carbonyl OH. You can put a line here, you don't have to. Okay, and then we're going to have carbon. This will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, carbon 8, carbon 9, carbon 10, carbon 11, carbon 12. So I'm drawing out lauric acid, okay? And remembering what you did in organic, every carbon's got 4 bonds. So we fill up everything with hydrogen. So this would be hydrogen, 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 hydrogen. So all of these CH2s, none of them attract water. You can't hydrogen bond when you don't have an O here. Like this can hydrogen bond right over here, this H. But none of these H's can hydrogen bond if you remember your intro chemistry. What you guys need to know is that this part over here, super duper non-polar. Non-polar. Or another word, they call this hydrophobic. It's absolutely terrified of water, okay? That's one characteristic I told you all lipids have. They do not like water at all. Okay, it's a little tedious drawing these out as an expanded, so let me show you how you can draw the same lauric acid, but as a line drawing, all right? So again, I'm going to put my carboxylic acid group over here. Okay. And then remember, this is carbon 1. So we're going to do a whole bunch of zigzags. Okay, remember how we did our line drawings in organic? Same thing. So here's carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's lauric acid. So when I have a structure for you guys, you're going to have to count all the carbons so you know which fatty acid we're talking about. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is lauric acid. So create some flashcards for yourself. Write down the name of the fatty acid and write down the number of carbons and tell yourself that these are saturated fatty acids. And what you'll have to do is recognize which fatty acid I've got. All right. If it's going to be 12 carbons, it'll be lauric. If it's 16 carbons, it's palmitic. If it's got 20 carbons, it's arachidic. All right. So those are the saturated fatty acids I need you guys to know. There's a really small one called butyric acid. Some books include it in the fatty acids, some books don't. Butyric acid is a pretty bad smelling fatty acid. It's just a 4-carbon one. So we won't worry about it, but you should know lauric, myristic, palmitic, stearic, and arachidic. Okay? Now let's learn how to draw, or actually name first, the unsaturated fatty acids. So these are I'm going to erase this. We'll start fresh, and we'll now do the unsaturated. And unsaturated means they have double bonds. Unsaturated fatty, I'll just write Fa for fatty acid. And you've heard, if you've had some nutrition, you've heard that unsaturated fats, healthier than saturated fats. Unsaturated fats have a much lower melting point, and that's why that you find them in oils. You find a lot of saturated fats in solid fat like butter or margarine or, the solid fat on a ribeye steak. So you get a lot of saturated in that. Any solid fat is filled with saturated fatty acid. Any liquid fat or liquid oil is filled with unsaturated fatty acids. So that's something nutritionally relevant to know. So what are the unsaturated fatty acids you guys need to know? Let's start off with palmitoleic. Palmitoleic is 16:1 delta 9. What does that mean? It means that it has 16 carbons and it has one double bond, and the location of that double bond is at carbon number 9. That's what this little, sort of like an acronym, it's like an abbreviation that will tell you what the structure is going to look like, okay? The next one is oleic acid, and this one is 18:1 delta 9, okay? These two are monounsaturated fatty acids. What does the term monounsaturated mean? It means it just has one double bond, okay? Monounsaturated, just one double bond. The polyunsaturated, I'm going to again write Fa for fatty acid. Sometimes they call them the PUFAs and the MUFAs. The monounsaturated fatty acids, palmitoleic and oleic. Polyunsaturated, these are the ones we need to know, and we'll draw their structure in a little bit. The polyunsaturated, we're going to do linoleic acid. Linoleic is 18:2 delta 9 and 12. What does that mean? It means it has 18 carbons, and there are 2 double bonds because it's poly, not mono. And where are the double bonds? At carbons 9 and 12. okay? Linoleic. Linolenic acid is 18:3 delta 9, 12, and 15. So again, a polyunsaturated fatty acid, it has more than one double bond. It has, in fact, 3 double bonds. Linolenic acid is at 18 carbons, 3 double bonds at carbons 9, 12, and 15. These two guys, these are called the essential fatty acids. If you've had a nutrition class, you may have heard of them. What does the word essential mean? Essential doesn't mean important. Essential in nutrition just means your body can't make them. So that means you need to consume them in your diet, okay? So the two essential fatty acids are linoleic acid and linolenic acid. So what that tells us is that all the other fatty acids we can make, we can synthesize them, we can use other molecules to make them, all right? But we can't make these two guys. All right, there's one more polyunsaturated fatty acid that I want you guys to know, and that is arachidonic acid. Okay, hopefully you could see this. Arachidonic acid. And this one is 20, has 20 carbons, colon 4 double bonds, all right? And it's at 5, 8, 11, and 14. So the double bonds are at carbons 5, 8, 11, and 14. What are the two essential fatty acids? Linolenic and linoleic. So you need to know the names of the fatty acids, how many carbons they have, do they have double bonds or don't they? Are they unsaturated, polyunsaturated, monounsaturated, or saturated? Okay, again, if you create some little flashcards for yourself and just practice all of this stuff, you'll be fine on any quiz or test. Okay, great. Next video, I'll draw some structures out for you for those fatty acids, the unsaturated, and then I'll hook them up to glycerol so that you can see what a triglyceride will look like. Because right now we've just drawn the fatty acids, that's it. Now we need to hook them up to glycerol to create triglycerides. Okay, good.